Mitsubishi. Welcome back to our classroom. Today, I'll be teaching you about the conservation of energy. What is an energy? Energy is the ability to move or transform other objects. Simply put, energy is the ability to do work. For example, energy is used when you're lifting, moving, or heating something. The most common unit of energy is the joule, or J. Other units that are used include the calorie, CAL, or cal, or watt hour, WH, and electron volt, EV. There are several different forms of energy, but I'll just tell you a few. These are not all of them, these are just some that would come up a lot. My first example is kinetic energy. This is probably one of the most, if not the most, common form of energy. We're all using it right now. Energy that an object possesses when it is in motion. So when I'm moving like this, I'm using my kinetic energy. Next is potential energy. Energy that an object possesses by being in a specific location or state. So it isn't happening, but it's like it could happen. It's potential. For example, one of the most important examples of potential energy is gravitational potential energy. So, for example, an object in a high place has gravitational potential energy because if it's pushed off of it, then it's free falling, then it's being affected by gravity. And then it's converting that gravitational potential energy into many other forms of energy. And then another form of energy is heat energy. The higher the temperature of an object, the more energy it possesses. But remember, everything has this. It's just a matter of how much. The next popular form of energy is electrical energy. It's just energy that's possessed by electricity that's used to power many things, like many tools, many machines, lots of stuff. And then another form of energy is light energy. It's the energy that's possessed by light. Now, I'll tell you about energy conversion. Energy can be converted from one form to another. For example, in hydroelectric power, the gravitational potential energy of water is converted to kinetic energy, which is then converted to electrical energy. This happens because the water is at first in a higher reservoir that then it let through a dam, which is sloped down, and there's a turbine inside of it, so that while the gravitational potential energy in the water is being converted to kinetic energy, that kinetic energy is used by the turbines to be converted electrical energy. Now I'll tell you about the most important thing that you must remember about energy: the conservation of energy principle. Energy can only be transferred into another form. It can never be destroyed nor created. So when a ball is at the top of a slope, there is no kinetic energy in it because it's not moving. But for example, if there's 200 joules of gravitational potential energy, then when it starts to roll down, there's more kinetic energy because while it's moving, and there's less gravitational potential energy, because that gravitational potential energy is being converted into kinetic energy. But the amount of energy stays the same throughout. Now, I'll give you a few examples of the conservation of energy principle. When a ball is dropped from a high place, gravitational potential energy is converted into kinetic energy as the ball falls. And some energy is wasted as sound and thermal energy because the ball becomes warmer as it goes down due to air resistance, and some energy is wasted through sound energy because it makes a soft thud when it hits the ground. Another example is an electric heater converts electrical energy into thermal energy to heat a room. In solar power generation, solar energy is converted into electrical energy through the solar panels. Now, I'll give you a few questions to test how well you understood what I was telling you. Which box is moving the fastest? A, B, C, D, or E? The answer is C. Everyone, please be honest. Tell me in the comments if you thought B was the fastest. Actually, it's not. According to the law of conservation of energy, the mechanical energy, which is a sum of kinetic energy and potential energy, is constant for A to E. Therefore, the place with the smallest potential energy has the greatest kinetic energy. C, which has the greatest kinetic energy, is the fastest. Because it's not on a ledge like A or D, and E isn't moving, and B still has some gravitational potential energy pulling him down. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.